All right, ladies and gentlemen, appreciate you finding some time to do your notes. Tonight we're going to be talking about negations. This is a little bit of a difficult subject for most people to get their head around, and it's not because it's all that difficult. It's just that there's some things that you have to memorize, and short of memorizing them, there's literally no way that you're going to get around that. So we're going to have to get it memorized if we're ever going to get any questions about the negations correct. So let's begin. You need to begin by looking back over your notes on reasoning, reread your notes, come up with a conclusion, a summary statement or two in order to finish up your Cornell notes from last time. Drop down a couple of lines, and let's look at negations. Today, your objective is the student will discover the meanings of the negations and apply them to provided conjectures. The date for these notes today is the 12th, September 12th, and they are for September, Friday the 13th, okay, for the 13th class. Press pause if you need more time, and then press play once you're ready to go. Okay, last time we discussed the conditional format, conditional statements, and the structure. And the structure was if P, then Q, where P and Q are just some statements. P represents information about the hypothesis, some type of an observation or a pattern that we have going on, and Q is the conclusion, the prediction about what is going to happen from there. We didn't really talk about what it's going to be used for or anything, but one of the things you probably have seen in the past, maybe you haven't really noticed it, and you definitely will see it this year, is this format is of interest in mathematics since almost all of our theorems are written in this manner. Okay, if you think back over the years, you will find that the theorems say if, and they state some kind of a condition, and then some type of a conclusion, like Pythagorean theorem. If you have a right triangle, then a squared plus b squared is going to equal c squared. That's one of the ones we're going to have a look at pretty deeply this year. You've seen it before, but we're going to look at it again. Okay. Now, what we're going to do is we're going to take the conditional form of a statement and we're going to rearrange it in several different ways to investigate the truth of it from other angles. Okay. Now, we said our conditional statements, our conjectures are assumed to be true. They need to be true, and if you can find any example that disproves it, then that is called a counterexample or a non-example, and it makes the conjecture entirely false. Well, we are going to be scrambling up some of our statements in different ways, and those are the negations, and then we'll reread them after they've been scrambled up and then decide how much truth there is to those statements. So again, remember that conditional statements are conjectures, and conjectures are supposed to be true. That's review from last time. And for this lesson, we are going to stick to one statement, and our statement is going to be a simple one. If it is noon, then it is daytime. Now, we're not doing anything crazy, not trying to read anything into this statement or dissect it on rocket science types levels. We are simply saying if it is 12 noon, which is 12 o'clock in the afternoon, then it is daytime, meaning simply this is typically a time of day where the sun is visible. So we're not talking about, ooh, it's a cloudy day or it's winter or whatever. Then that means the sun may not be shining or anything like that. Daytime simply means the time between sunrise and sunset. Okay, the first negation we're going to look at, and there are three, is called a converse. Okay, and what a converse does is it takes the conditional statement and it switches the positioning of the hypothesis and conclusion. Now remember, the hypothesis is the information that's associated with the word if. Doesn't mean the word if, it's the information that's connected to if. If something that is observed, and then you have a conclusion. Okay, so we're going to switch the positioning of the hypothesis and conclusion. Okay, so our conditional statement was if it is noon, then it is daytime. Okay. And the converse would be if it is daytime, then it is noon. Okay, so all we have done here is taken the hypothesis and the conclusion and repositioned them in the statement. Now, you have to evaluate the truth of a converse on a case-by-case basis. Okay, you may have started off with a completely true conditional statement, but that does not guarantee that the converse is going to be completely true. In fact, there are three categories for the truth here on the converse, and those categories would be always true, sometimes true, or never true. Okay, so let's think about this statement. If it is daytime, then it is noon. Would this be always the truth, sometimes the truth, or never the truth? Okay. Well, clearly, right now, I am standing in my classroom and I am recording a video at 4:25 p.m. So right now, to me, it is daytime. So the hypothesis is true. Okay. The conclusion states it is noon. Well, no, it's not. It is 4:25 for me right now, so it is clearly not noon. However, is there a time of day where, yes, it is daytime and yes, it is noon? Clearly, that time does exist. So we can see instances where this statement is not true. We can see instances where it is true. So in this case, this converse, we would state that it is sometimes true. Okay? Don't think that all converses are going to be sometimes true. It simply has to do with what the original statement is talking about. In this case, sometimes this is the truth. The second the second negation that we're looking at is called an inverse. And what an inverse is going to do is it's going to take a conditional statement and it's going to negate both the hypothesis and the conclusion. By negate, we mean it's going to take the meaning of the hypothesis and the meaning of the conclusion and make them mean exactly the opposite of what they were trying to mean. Okay, so looking at the conditional statement that we began with, if it is noon, then it is daytime. Okay, well, we're looking to negate these pieces of information. So what is the exact opposite of it being noon? Now, don't get reading into it or anything like that. Don't think, oh, the opposite of noon is midnight. Okay, now the opposite of noon is simply not noon. Okay, and daytime, the opposite of daytime isn't necessarily nighttime. Okay, because daytime and nighttime are only 5 minutes apart from each other when the sun sets. Okay, the opposite of daytime is simply not daytime. And that's the way the inverse tends to work. It simply installs a negating verb, or, well, actually, I don't know what you call not. Okay, probably a helping verb or something like that, an adjective. I don't know. Maybe one of you English majors can straighten me out on it. But all it simply means we're just reversing the meaning. So instead of it is noon, then it is daytime. The inverse would say if it is not noon, then it is not daytime. And once again, okay, you have to evaluate this on a case-by-case basis. There's not really any way to predict whether an inverse is going to be true or not. It depends on the original statement. So let's read it. If it is not noon, then it is not daytime. Okay, well, once again, it's now 4:28 on my clock, so it is definitely not noon. Does that mean it is not daytime? No, I can look out my windows right now and I can see there is daylight. Okay, it is daytime. So I can see instances where this is not true. Okay, but 6 hours from now, it's going to be nearly 10:30. At 10:30, is that going to be not noon? It's absolutely not noon at 10:30, and at 10:30 it is definitely not going to be daytime. So there are instances where it is true. So we can see where it might be false, we can see where it might be true. So once again, the statement that we're making about the inverse in this case is that it is sometimes true. And once again, you don't just fall into the trap of thinking inverses are always going to be sometimes true. It just depends upon the problem. Okay, the third and final negation that we are looking at is called the contrapositive. Okay, now again, a contrapositive is going to take a conditional statement, and this one just about messes it up as bad as it can. It's going to negate the information, just like an inverse did, and switch the position of the hypothesis and the conclusion, just like a converse did. So another way of thinking about it is that a contrapositive is actually the inverse of the converse. So if you can remember what converse is and remember what inverse is, contrapositive does both of them at the same time. So let's see how it applies to the statement we've been talking about here. Okay, our conditional statement is if it is noon, then it is daytime. Okay, well, we are going to perform converse and inverse at the same time. So instead of if it is noon, then it is daytime, our contrapositive would say if it is not daytime, then it is not noon. Okay, now once again, just like all the others, you have to evaluate it on a case-by-case basis. Okay, but if you have a good conditional statement to begin with, meaning there are no counterexamples or non-examples to disprove it, your contrapositive ought to come out always true as well. Okay, but again, never a bad idea to just read the statement and try to evaluate the truth on a case-by-case basis. So let's look at this one. If it is not daytime, okay, then it is not noon. Okay, so let's figure out when it is not daytime. A lot of you have probably waited until nighttime to look at your notes, so it is probably not daytime right now for you. So if it is not daytime, is it true that it is not noon? Well, absolutely it is. Okay, noon happens during the daytime. So if the hypothesis is going to force us out of daytime, then there is no chance that it is going to be noon. So reading this one, we started off with a very solid conditional statement that could not be argued with, and as a result, we end up with a contrapositive that is also solid and cannot be argued with. Okay, and what we're going to see is that the strongest of the theorems that we have in mathematics, they have converses, inverses, and contrapositives that are all three always true as well. And that's going to be quite helpful because it allows us to use things like the Pythagorean theorem in different ways. We don't just use it to solve for missing sides of a triangle. We can also use it to determine if we have a right triangle or not. Okay, that's from things like the converse and the inverse and the contrapositive. But we'll get to all that when the time comes. Okay, one more example here. We're going to look at a new conditional statement. We will evaluate the truth of the converse, inverse, and contrapositive after we identify those negations. Okay, so here's a new statement. If an angle measures 90 degrees, then it is a right angle. Okay, so let's say that's our conjecture. So this needs to be always true. So let's think about it for a moment. If an angle measures exactly 90 degrees, does that guarantee that it's going to be a right angle? Okay, absolutely it does. There's no way to get around that. It fits exactly into the definition. So we've got a very strong conditional statement, very strong conjecture right off the bat. Now, let's think of the converse. So what is it that a converse does to a conditional statement? Converse takes the hypothesis and the conclusion and reverses their positioning. Okay, so the information associated with if and the information associated with then is going to reverse places. Okay, so a converse, and there's different ways to word it. When you write your converse and inverse and contrapositive, you just need to make sure that it actually makes good sense in the English language. But one possibility for the converse would be if an angle is a right angle, then it measures 90 degrees. Now take a moment here and notice I didn't move all of the words from the hypothesis and all of the words from the conclusion, just because the sentence still needs to make sense. And if you said, if it is a right angle, then an angle measures 90 degrees, there can be some ambiguity in that. But just keep the sentence making sense. Let's see if the converse makes any sense here or not. Let's evaluate the truth. If an angle is a right angle, then it measures 90 degrees. Is this always true, sometimes true, or never true? Well, if the angle is a right angle, if we're forcing it into that vocabulary term, does that guarantee that it measures 90 degrees? Absolutely it does. Okay, so we started off with a strong conditional statement, and we have a strong converse to go along with it. Next, the inverse. Okay, what does an inverse do? It takes the hypothesis and the conclusion and it negates them. So if an angle measures 90 degrees, then it is a right angle. An inverse would most likely say if an angle does not measure 90 degrees, then it is not a right angle. Okay, so let's think about the truth of this statement. If an angle does not measure 90 degrees, does that guarantee that it is not a right angle? Well, I think it's pretty clear. Once again, but if you force it away from 90 degrees, you have forced it away from the definition of a right angle. Yeah, that is always true. So once again, okay, we got a true statement. We ended up with a true converse. We ended up with a true inverse. Let's examine the contrapositive. Okay, what is it that a contrapositive does to a statement? It takes the inverse of the converse. So we're switching the hypothesis and conclusion and negating them at the same time. If an angle measures 90 degrees, then it is a right angle. Contrapositive would be if an angle is not a right angle, then it does not measure 90 degrees. That's one possible wording for it. Well, again, you have to evaluate the truth on a case-by-case basis, so let's see what we think. If an angle is not a right angle, does that guarantee that it is not 90 degrees? Once again, this thing is dancing all over the definition of a right angle. If the angle is not a right angle, then there is no possible way that it could measure 90 degrees. So once again, always true. Like we said, the strongest of the rules and definitions and theorems that we have in mathematics are going to have conjectures, and then converses, inverses, and contrapositives that are always true as well. But once again, one last time, you have to read them on case by case and make those decisions one at a time. Okay, that's the end of the notes. I will see you in class on Friday, and appreciate you dropping by and taking your notes down.